Hello everyone, welcome to the very first video of this channel. Now my day job is to write documents and convince people that I know stuff. So trust me when I say that I'm totally qualified to talk about this topic. Today's topic is the AWS SDK for Rust. The AWS SDK for Rust was in developer preview for a long time and it was made GA during the last reInvent. Let's take a look at how to use it in your code. For our sample scenario, we are going to talk to the CloudTrail API and get a list of trails that are in the region. Now this video is intended for folks who already have a basic idea of Rust, but I'll also try to explain some of the new things that are in the AWS SDK for Rust for people who are coming from different languages. General usage wise, the Rust SDK is similar to other language SDKs you might probably have worked with. You basically load the configuration from your environment away from any other source and then build the client instances that you want to work with. Say for different services, you would build different client instances. And then using those client instances, you would start making API calls and then processing the results from those API calls. Now, this would be the general structure of a program that would work with AWS APIs. Now, if we go to the AWS SDK for Rust landing page and then into the developer guide, we can see a few details that are different from other language bindings that you might have worked with. One is the usage of async features in Rust. So this essentially forces you to make the rest of your program async as well. The other detail that you might notice is that for different services, you have different packages, or in Rust you call them crates. You have different packages to import into your project. Now this will be new if you are coming from, say, Python, where you have all the language bindings for all the services inside one package, which is Boto3. In Rust, if you are working in different services, you have to import the crates for those different services into your project. This helps to keep the size of the binary small and also keep the amount of time you would spend on compiling maybe useless code. Now let's go and see how we can work with these crates. So the first step of any Rust project is to set up the project using Cargo tool, right? So let's name our project AWS Hello World and mark it to be a binary project. If you're new to Rust and Cargo, this is basically setting up a template project structure with a git initialized directory. So it's basically setting up best practices right from the start. Let's open this project in our editor and see the content. We can see Hello World in the code that has been already generated for us. If we navigate to the Cargo toml file, we can also see we have no dependencies at the moment. Let's change that. Let's add crates that enable us to work with the AWS SDK. We're adding 3 crates here. AWS config is the crate that contains the logic to work with AWS client configuration, which is kind of common to all the services you can find on AWS. AWS SDK CloudTrail is the crate that contains the language bindings to work with the CloudTrail API. Like I mentioned before, to work with different AWS services, we have to use different crates. This is something different from other language SDKs, especially something like Boto3 if you're coming from Python. Lastly, Tokyo Crate provides us an async runtime needed to actually utilize the async features in Rust. You'll notice that I'm also specifying a few custom features for each crate. The most important here is Tokyo Full feature, which provides the actual runtime. There is behavior version latest feature for the AWS SDK crates as well, which kind of enables us to work with different customizable configuration options. Now that the crates are added to the project, we can start writing our code. Let's start by making our entry point an async function. We add the macro to mark this function as the main function to be executed by Tokyo runtime. And we also change in the main function signature to specify the return type to be a result. The error type here is something we import from the CloudTrail crate. But if you are working with different AWS services, this could be a parent error type that captures all of the errors that could come from different services. Now let's just make sure everything's right. Let me do a cargo run and we'll get a compiled and executed output of Hello World. Right, let's get on to write the rest of our code. The first step of working with the AWS API is to load the client-side configuration. This can be provided through several means actually. It could be configuration options in the CLI configuration files. It could be environment variables, or if your program allows, the CLI arguments could also provide overriding values. So when it comes to configuration loaded from the environment, priority or the overridden values should also be considered. For an example, if you provide a value for, let's say, region that your CLI has to work with through the AWS CLI configuration file, but you also specify the environment variable AWS_region, the CLI should use the value that is provided through the environment variable. That is the default behavior users will expect from a tool that works with the AWS API. The easiest way to implement this configuration loading chain is to use the load from environment function provided by the AWS config crate. This returns an SDK config instance that we can pass to the client creation function. Notice that we had to put a wait to actually get the load from environment function to execute and return the result. Now we're actually working with async features here, so you will see async and await syntax being used to actually get the concurrency features going on. Right, let's create our client instance next. The client instance is returned from a simple new function in the CloudTrail crate context, and we pass a reference of the configuration instance we just loaded by reading input from environment variables. After that, it's a matter of making the API call of choice. So for this example, we need to get the list of trails in the current region, right? So the API call we need to use is the list_trails. So if you go and take a look at the documentation for this method, we can see that it returns a future when completed, returns a result that may contain a reference to an array. So this array would contain trail info instances. And each trail info instance contains a field called name that we can use to output the trail name. So based on this information, we can write a loop that iterates through the sum part of the result and output the trail name. Let's compile this and get our first error. Now what's missing here are the AWS credentials. The load from environment function is trying to look up the credentials to make the API calls, but we haven't really specified any credentials in environment variables or any configuration files. So let's go ahead and fix that. I'm going to get some temporary credentials with permissions to talk to the CloudTrail API and populate my environment variables with them. With these present, our tool can list CloudTrail trails and provide a successful output. Although I just have a single trail in this region, so it's just going to be a single line. Now roughly speaking, this piece of code covers almost 90% of the use cases that you will have. Most of the time your workloads will run in an environment that has access to either some type of temporary credentials or a way to actually get those temporary credentials from an AWS API. But there could be cases where you have to customize the way your configuration is loaded. For an example, you might want to hard code the region that you want to work with. Let's say you have data sovereignty requirements coming down from the client. Or you might be in a scenario where you need to load the credentials for your tool, the credentials to work with the AWS API from non-standard methods. In that case, you can use some of the functions and methods provided by AWS config and a few other related crates to customize the way you load your configuration. For an example, if you wanted to hard code your region, this is how you would do it. You would use a function called from environment instead of the load from environment function. In fact, load from environment is a wraparound from environment function. We can customize a couple of options. We can provide values like region, retry counts, timeout values, or we can provide a different implementation for the underlying HTTP client as well. You can also write this code in a way that provides a fallback value for the region if the configuration loading fails to find a proper value for it. We do this by using a struct called region provider chain. This is a really good way to have your code behave in a predictable manner when the external input is not that predictable. Another similar method is provided in the same module for providing fallback values for credentials loading. Now let's briefly look at how to customize credentials loading process. One really bad way is to actually start hard coding credentials in the source code. Now I'm just mentioning this as an option, but this is never really an option. You should never hard code credentials in the source code, even if it takes maybe another half an hour to write the code that actually, let's say, read your options from environment variables instead of just hard coding them in the source code. Accidentally committing your credentials to a public Git repository is never going to be good for your mental health. So to do this, we have to add another crate to our project, AWS Credential Types, and we need to add an extra feature called Hardcode Credentials. This provides us a struct with a function to create an instance of credentials where we can provide string values for AWS credentials. Then we can provide this credentials instance as the credentials provider when we actually build the configuration instance. Unlike the previous executions, I'm going to expect this code to fail, because even though I have proper credentials in the environment variables, I specified wrong credentials in the source code. So those are the credentials that will get loaded into the configuration object, and that's going to fail when the API call happens. So you can see that the error message we have is about the security token being invalid. So let's say your workload runs in a place that doesn't really have access to any method that could generate temporary credentials, right? So instead of hard coding credentials in your source code, a better design would be to actually have your credentials, the secret values, in an external secret store. This could be, let's say, a HashiCorp Vault instance, right? So you can write your code so that it talks to the external secret store, get the values, and then build the credentials instance. We do this by writing a custom credentials provider. Now, the documentation in AWS Credential Types Crate goes deep into this implementation, but it's really easy to actually write a custom credentials provider. You first define a struct to represent your credentials provider implementation, and then you start implementing the provide credentials trait for the type that you specified. That's just one function to actually implement provide underscore credentials, and in this function you should return the credentials or the result of the credentials that you retrieve from the external store. So in this case, I'm again hard coding the credentials instead of actually talking to an external store. I don't have HashiCorp Vault, for example, running. That could be a different video. But again, I'm expecting this code to fail because we are specifying wrong values for the credentials, even though we have proper values in the environment variables. So as you can see, it's the same error that we got before the invalid security token. So that was a brief look at the AWS SDK for Rust. Pretty soon this will form the boilerplate code you will write for more advanced use cases like Rust Lambda functions. If this video was useful to you, please take some time to like, comment and subscribe. I'll be making more videos on similar topics, mainly around cloud development in the future. But for now, that's me. Thanks for watching.